From the very moment the great explosion erupted, our universe began its eternal dance of motion. Nothing stands still. The Earth orbits the sun revolves around the center of the Milky Way, and even galaxies never cease moving in the vast universe. But what has set everything in perpetual motion? Why does the universe keep changing, never coming to a halt? Astrophysicist Edward Gomet, who is also the director of education at the La Cumbres Observatory, shared with Live Science magazine. Everything depends on how the universe and the objects within it are formed. Scientists believe that the universe originated from a massive explosion, starting from an extremely dense singularity, then expanding at an incredibly rapid rate and gradually forming everything we observe today. Motion is not only the result of the interaction between forces, but also due to gravity pulling planets and stars closer together. The passage is also a legacy of the chaos and immense energy generated by the event that birthed the universe. It was like the mark of a new journey unfolding. Carol Antrishan, an astrophysicist and community project scientist for the Hubble Space Telescope at the Space Telescope Science Institute in Baltimore. Thus, the origin of the universe is motion itself, and therefore, motion has been woven into the fabric of the cosmos from the very beginning. Therefore, one of the reasons objects in the universe move is due to the expansion of space, but this effect only occurs over extremely vast distances. We can only truly observe this phenomenon in objects that are far apart or at very great distances, because they themselves do not necessarily move through space. The space between objects is continually expanding. However, on a small scale, rotational motion is the primary factor governing objects in space. This rotational motion is also a common feature in the universe, as all objects rotate. This phenomenon originates from angular momentum. When two objects in the universe come close to each other, the gravitational force between them will pull them closer together. If no collision or separation in different directions occurs, they typically begin to orbit each other. This law affects not only the smallest mineral particles, but also governs even massive galaxies, shaping the motion of all objects in the universe. Gourmet stated that our solar system was formed through a complex process, originating from the swirling of a cloud of cosmic matter. When a massive cloud of gas and dust begins to spin, the centrifugal force generated by this motion pushes the material outward, making them gradually flatten and spread out, forming a vast electric area. This process is the reason for the formation of planets orbiting the Sun. Initially, the solar system was just a swirling cloud of gas and dust. Over time, gravity combined with the conservation of angular momentum pulled this material together, forming the central star and the planets. This angular momentum also plays a crucial role in maintaining the rotational motion of the entire system. Ensure the planets keep orbiting the Sun continuously without stopping. But the way the universe operates is completely different from what we predicted based on existing observations. It spins as a single, seamless solid mass, not at all like a collection of billions of individual stars. In theory, stars at the edge of the galaxy should rotate more slowly than those near the center. But the reality was far different, and this was one of the earliest signs that the universe was hiding something mysterious. What the naked eye cannot see, what we now call dark matter. When first discovering this phenomenon, scientists thought their model might be missing a certain element. But after many meticulous observations and extensive research, they gradually realized that dark matter was indeed the answer. Dark matter does not interact with light, so we cannot observe it directly with conventional instruments like telescopes. This stems from the nature of dark matter. It does not emit, absorb, or reflect light in any form, making it completely invisible to conventional light-based observation instruments. This ability raises an important question. How can we be certain of the existence of dark matter? Although it cannot be observed directly, dark matter still possesses mass and interacts with other massive objects through gravity. The primary way scientists identify and study its existence is as follows. For example, the motion of stars in a galaxy, especially those far from the center, indicates a much stronger gravitational pull than predicted if only the observable mass of stars and planets is accounted for. This gravitational force is believed to originate from dark matter. Dark matter not only plays an essential role in maintaining the structure of the universe through gravitational force, but it may also participate in the exchange of angular momentum, a physical quantity that describes the rotational motion of objects. Angular momentum is a crucial factor that helps explain why all objects in the universe are constantly in motion, from planets orbiting the Sun to galaxies rotating around their centers. Through angular momentum, dark matter not only affects the stability of celestial systems but also influences how galaxies interact and evolve over time. This demonstrates that the influence of dark matter extends beyond conventional gravity, opening new avenues of research in cosmic dynamics. Ultimately, motion is the fundamental and indispensable element of the universe. It is not merely a physical phenomenon but also the foundation for all processes of transformation and operation within this cosmos. In reality, when we talk about the universe, we're referring to a system in constant motion, where everything, from the tiniest particles of matter to the most massive galaxies, is perpetually in movement. This is manifested not only in the motion of planets, host stars, or the vast universe itself, but also present in every chemical reaction and physical phenomenon occurring at the microscopic level. Motion is considered a manifestation of energy. When observing chemical reactions or physical phenomena, we notice that they all require energy to occur. In a chemical reaction, molecules require sufficient energy to overcome the activation energy barrier, leading to changes in bonds and the formation of new substances. In physics, the motion of large objects such as planets, stars, or even tiny particles like electrons requires energy to maintain their orbits and states. Motion not only shapes the structure of the universe but also plays a decisive role in the formation and evolution of life. Life on Earth is sustained by continuous biological processes, ranging from the activity of biomolecules within cells to the circulatory and respiratory cycles in living organisms. Whether it's movement at the cellular level or the entire body, both require and consume energy. In short, motion is not merely a physical phenomenon, but also the origin and driving force behind all processes in the universe. From the formation of celestial bodies to the emergence of life, all are shaped by motion and energy. It can be affirmed that movement itself has shaped and nurtured life in the universe, turning it into a system both complex and extraordinarily wondrous. Although the universe is not a conscious living entity, the existence of movements demonstrates that chemical and physical processes are constantly at work, creating ceaseless transformation.